Hello guys, in my previous video I have explained about source transformation technique and how to transfer the voltage source to the current source and current source to the voltage source. And at the same time I have taken two very simple circuits and I transferred from voltage to current and current to voltage source. Now this is problem number 1 and we need to find power delivered by 50-volt voltage source by using source transformation technique. Now see here, you already know the practical voltage source. The practical voltage source means what? The ideal voltage source are connected in series with the internal resistance R. Okay, now practical current source means what? The ideal current source is connected in parallel with what? Internal resistance Ri. Suppose see only if resistance is connected in series with the voltage source, you can transfer from voltage to current, or if current source is connected in parallel with the internal resistance Ri, then you can transfer current source to what? Voltage source. Now what you have to find here, you have to find the power delivered by 50 volts. Now see, this is the 50 volts. Now here you need to understand what is the power delivered by 50 volts. What is the formula? P equal to VI. So here by 50 volts means instead of 50 voltage, you will keep 50 into. Now I, what is the current delivered by this 50 volt source? Now if you know the current, then you can find the power delivered by 50 volt voltage source. So you have to solve using source transformation technique. Before going to solve this problem, you have to analyze this circuit. Okay, see here you have what? Voltage and resistance, and here you have voltage and internal resistance, right? So you can transfer this voltage to current and this one also voltage to current. Now here this current source and resistor are connected parallel. Therefore this current source you can transfer from current to voltage. Now out of these three steps, out of these three ways, which way we need to choose? See here, if I transfer this particular voltage source to the current, now this we don't have voltage source, right? Then we will go to the current. Then what is our ultimate goal? We already know the voltage and you have to find current. So you should not disturb this particular branch and you should not disturb this particular branch. So can we convert this particular current? The resistor is connected in parallel with what? Ideal current source. Can you convert this one to the voltage source? Of course. So V equal to what? IR. So you know the I means what? 10, and you know the resistor is what? 2. So 10 into 2, this is what? 20 volts. Therefore you need to redraw the circuit. So here this one I'm not changing. This is what? 50 volts, and this is what? 5 ohm. Now here see, if I convert this particular current source to the voltage source, what would be the my voltage value? 20 volts. And see here, whatever the resistor is connected in parallel with the current source, the same resistor you have to connect in series. So what is the value? 2 ohm. Now of course you have another voltage source and it is connected in series with the internal resistance. This is your modified circuit, right? This is 3 ohm. Now see, this is the circuit after converting from current source to the voltage source. Now what is your ultimate goal? You have to find the current delivered by this 50 ohms. So in our previous classes, I already explained about mesh analysis and nodal analysis. See, if I take mesh analysis, so we have two loops, loop 1 and loop 2, you can find current. So by using nodal analysis also, you can find the current. So of course, you can choose either mesh or nodal. Here I want to choose the nodal analysis. So you are already familiar with the nodal analysis, right? First, you need to identify how many principal nodes you have. So here, this is what our principal node. So I can say this is V1. So we don't have any principal nodes, only one. And we have what? One reference node. This is V reference equal to 0. Then how many equations you will get? Total number of nodes 2 minus 1 equal to 1. You will get one equation. Now I can apply KCL at super node. So before apply super KCL, I should consider current is leaving to the each branch from super node, from the principal node. This is I1 is leaving from V1 towards this branch, and consider this is I2 is leaving from V1 towards this branch, and this is I3 is leaving from V1 towards this branch. If I apply KCL at V1, so I can write I1 plus I2 plus I3 equal to 0. Yes or no? Yes. So you already know how to write I1, I2, I3. In my previous classes, I have explained. Now this particular 5 ohm resistor, one end V1 is connected, another end 50 ohm is connected. So therefore this is minus 50 by R means what? 5. Current I equal to what? Always V by R. Numerator voltage and denominator resistance. So if you don't know how to write this one, please watch the previous video of a of nodal analysis, so that you will understand, right? So for this I2, for 2 ohm resistor, one end V1 is connected, another end 20 ohm is 20 volt is connected, therefore minus 20 by 2. So for I3, one end V1 is connected, another end, what is this voltage source? 10. So this is minus 10 by 3. See here, equal to 0. Why I have written minus 50, minus 20 and minus 10? See, this is your assumed current direction from V1 towards this voltage. But actual current is flowing from what? From like this. So from this, as we are using plus and minus, current is flowing like this. This is actual current and this is your assumed current. So these both are in opposite. So I have written minus 50, minus 20 and minus 10. So we need to find V1, right? So if I take V1 common, I can write 1 by 5 from here, and from here I can write 1 by 2, and from here I can write 1 by 3. Then what is the left here? So it is minus 50 by 5. This is the constant from this term, and here minus 20 by 2, and here minus 10 by 3. So what is our goal? We need to find V1. Therefore V1, 1 by 5 means what? 0.2, and 1 by 2 means what? 0.5, and 1 by 3 means what? 0.33. Now if you calculate all these things, just for time saving, I'm writing the value 23.33. If you calculate this one and take to the right hand side, you will get 23.33. Therefore V1 equal to what? 23.33, and by, if you add all these things, you will get what? 1.03. So if you calculate this, if you cancel this one, you will get 22.65 volts. So what is the node voltage here? 22.65. And what we have to find? We have to find current I1. So what is the formula for I1? I1 equal to, you already written here. So V1 minus 50 by what? 5. So you know V1 node voltage, this is 22.65 and minus 50 by 5. So if you calculate this one, I1 will be minus 5.47 ampere. Now you have to understand why you get minus 5.47, because current may be 1 ampere, 2 ampere or 0.5 ampere, but it will not be in the minus, right? See here, this minus you get because your assumed current direction is what? From V1 to this side. Okay, this is assumed current direction. But what is the actual current direction? As you are using 50 volt, the actual current direction is this one. Therefore, even if you get minus, you have to take I1 equal to what? 5.47 ampere, because this is your actual current direction. Clear? Now see, we need to find power delivered by this 50 volt voltage source. P equal to VI. What is the voltage? So 50 volt into what is the current delivered by this particular 50 volt? So you already find this one, 5.47 ampere. So here P equal to what? 273.5 watts. So like this, you can use source transformation technique in order to find some unknown parameter in the circuit. So I hope you understood how to find the power delivered by this 50 volts using source transformation technique. Okay, thank you so much.